Hello and welcome to this online lecture on pushdown automata, which falls under the study of automata and theory of computation. This session will cover the fundamental aspects of PDA. Anyhow, if you want to apply some intuition about PDA, you may visualize PDA to be an epsilon NFA with an additional feature, which is nothing but a stack memory. Let us try this exercise. Can you devise the finite state machine that identifies all strings with equal number of zeros and ones? Pause the video for a while and prepare your solution, but don't be long. Actually, there won't be any FSM for this particular problem, as we know that in FSM there is a single head to read the input symbol. Later, the control unit decides whether to change state or not. And next the head moves right to read the next symbol. Coming back to the exercise, I guess you have already realized that the particular language requires additional counter memory when it is modeled over the state machine. As the NFA or DFA has no memory to work with, here we need a more powerful machine. Hence, the concept of pushdown automata has been introduced that implements a stack memory. It won't be inappropriate if we say the PDA is more capable than the finite state machines but less to the Turing machines. Similar to FSM, there are two types of pushdown automata: deterministic pushdown automata and non-deterministic pushdown automata. Since the non-deterministic pushdown automata defines all the context-free languages, we will only consider the non-deterministic one for this session. Moreover, at the stack, the PDA has two operations, the push operation and the pop operation. In a PDA, we'll have two heads. One head reads the input from the tape, where the other one operates on the stack. The PDA also decides to change the state or not. Furthermore, the machine needs to identify whether to pop the stack top or push a symbol to the stack. Later, the tape head moves to the right cell. Now let us focus on the formal definition and transition notation for the PDA. The pushdown automata is a set tuple, so these tuples are Q, S, tau, del, Q naught, tau naught, and F. I don't want to imitate the textbook for the transition notation. We'll use the most obvious approach. So here, to define a transition, we need to consider three parameters. Alpha 1, which is the input symbol, alpha 2 to be the symbol that would be popped from the stack, and alpha 3 is the symbol that will be pushed to the stack. Now it's time to implement the pushdown automata. Hence, we'll consider the previously stated language of equal zeros and ones. Before we proceed further, first let us design the logic for the machine. Remember, in PDA, we have a stack memory which is an one-dimensional array. So we need to develop our solution where the stack will act as a counter. Again, please bear in mind that while reading the input, PDA can have four different types of operation. These are the push, pop, both, and none. This is a big hint for our solution since we just need to decide our stack operations for zeros and ones. So if we push something to the stack for every instance of 0 and later pop that something for every one, once we finish reading the entire string, return to the initial phase of the stack, we may say the string has equal number of zeros and ones. Now let us see the state diagram of the PDA. You may see that the PDA starts from state A. While reading the first input symbol, the machine pushes a hash symbol to the stack as a marker and changes to state B. We use such marker to spot the initial phase of the stack. Moreover, as stated earlier, the non-deterministic nature of the PDA allows such movement. In state B, if the machine reads an input 0, it will push one cross symbol to the stack. Since we have 3 zeros in the input, the stack is populated with 3 crosses. Moreover, at B, if the input is 1, the machine moves to state C and pops 1 cross. It will continue to pop 1 cross for every instance of 1 in the state C. Once the machine reaches to the end of the input string, it will try to pop the hash symbol from the stack.